All right, here we're just going to review how to find solutions, how to find the number of solutions, and then how to graph a parabola. So the first question is asking us to find the solutions of the function. So my first step is going to be to try to factor that. Factoring tends to be quicker than using the quadratic formula, so I'm always going to use that first, but I always have the quadratic formula as a backup. I can use that to check my answer, or if I'm just more comfortable using the quadratic formula, I use that. So if you want to, you can use that. I'm going to try to factor it at least. So I see that all of those are divisible by 6, so that's my first step. I'm going to divide that by 6, I'm going to divide that by 6, and I'm going to divide that by 6. That gives me y equals 6 times x squared minus x minus 3. I'm going to keep trying to factor that, but I really can't. I'm thinking about something that multiplies to -3 and adds up to -1. That doesn't exist as a whole number, so actually doesn't exist as a rational number either, so I can't really do that. So I'm going to use a quadratic formula, but I'm only going to use it on the stuff that's in the parentheses. I just cut those numbers down, so it's going to make the problem a little bit easier at least. I don't have to deal with as big of numbers. My new a is 1, my b is -1, and my c is -3. I don't use any variables, I don't use any x's in there. I'm just taking the a, b, and c, the coefficients and the constant, and plugging them into my quadratic formula. So I'm going to write that up top. The quadratic formula is -b plus or minus the square root of b squared minus 4ac, all divided by 2a. And now I'm going to substitute my a, b, and c into that formula. I see that I have a -b in front. That's the very first part of the quadratic formula. It's -b, and my b is a -1. I'm going to change that right away into a +1. Plus or minus the square root of -1 squared, that's b squared, minus 4ac, all divided by 2a. Sorry, I should replace that also. That's going to be 2 times 1. So this is going to tell me the solutions, and this is going to tell me the 2 solutions because I'm adding and subtracting. That's really where the 2 different numbers are coming from. That plus-minus symbol is telling me to split this into 2 separate problems, but I'm not going to do that yet. I'm going to simplify it as much as I possibly can and then split it up. So basically, I need to do everything inside that square root symbol. So I'm going to do 2 steps in one. I'm going to do -1 squared, and I'm going to multiply out everything over here. -4 times 1 times -3. So that gives me that x is going to be 1 plus and minus 1. -1 squared is just a +1 plus 12 divided by, actually I'm going to do 3 steps in one. I'm also going to do that bottom part. 2 times 1 is just going to simplify to 2. Okay, so all I did really was simplify a little bit inside of the square root. I did the square of -1, and I multiplied some stuff together. I also simplified the bottom into just 2 instead of 2 times 1. Now I'm going to add together 1 and 12, and I'm going to do the square root of that number. I just don't want to have to write out each step, so I know I'm going to do the square root of whatever that gives me, which is 13, and that's going to be x equals 1 plus or minus the square root of 13, or I'm actually going to simplify that right away. That is 3.60, all divided by 2. So this is where I split the problem. I'm splitting that into 2 separate division problems. X equals 1 plus 3.6 divided by 2, and x equals 1 minus 3.6 divided by 2. You can put the 0 on it or not, either way. 3.6, 3.60, those are the same thing. Now I'm actually going to simplify those, so I do the top first, and then I divide by 2. So I'm going to add these 2, and then divide that by 2. That would give me 2.3. I'm going to subtract these 2, and then divide by 2, so that's -2.6, divided by 2 is negative 1.3. Those are my two solutions. If you rounded that slightly different, that's okay. You can also simplify these as radicals, but right now we're just going to focus on using decimals to represent these solutions. Those are my two answers, and I can always take those and plug them back in. You take 2.3 and plug it in for both x's, you should get 0. That's what a solution really means. It means that when you plug in that x value, you should get 0 as your y value because it's an x-intercept. It's where this line, this curve really, is hitting the x-axis. I'm going to do the same exact steps for the second one. I'm going to try to factor this. So I'm going to factor a 2 out to start out. That gives me 2 times 3x squared minus 4x minus 15. So I was able to factor out a GCF, and I'm going to be able to factor by grouping here. I'm going to multiply a times c together, which would give me negative 45. And I'm thinking about what's going to multiply to negative 45 and add up to that negative 4. That is going to split into a negative 9x and a positive 5x. Because negative 9 times 5 is negative 45, and negative 9 plus 5 is negative 4. So now I have that term split up. Now I'm going to group my first two, and I'm going to group my second set, my last two there. Sorry, I'm just scribbling that out so it doesn't get confusing. So I have my groups now. Now I have to factor out whatever I can from the first group and whatever I can from the second group. So I'm going to divide this by 3x. That's the greatest common factor between those. That gives me 2 times 3x times, that's going to give me just x minus 3. That means my second group has to also be x minus 3. So you have to think about what are you going to factor out of there. Really, it should still be the greatest common factor, but what are you going to factor out to get that to turn into x, that to turn into a negative 3? That would end up, that would end up as a positive 5 as the greatest common factor that gets factored. So I write positive 5 in front of that second group. Now I have my two factors. So I have two, really it's three factors. 2 times 3x times x minus 3. That is just factoring it so far. Now I want to think about solutions to those factors. So I'm thinking about what will make this thing equal to 0, which means I'm thinking about what's going to make each of those factors equal to 0. What makes 3x plus 5 equal to 0, and what makes x minus 3 equal to 0. So I have three factors. Only two of them are really fruitful for solutions because I'm just looking at an x in that one and an x in that one. The 2 doesn't have an x attached to it, so it actually won't be meaningful for a solution. But these two do give me solutions. The solution from that is negative 5 over 3. The solution from this one is a positive 3. If you're not totally comfortable with factoring, you can use the quadratic formula and it should give you those exact same two factors. From a graph, this is a whole lot easier as long as we can see those points clearly. The root or solution or x-intercept, those are all the same thing. On that graph, it's just that point, which is 0, 0. So you can list it out like that as an ordered pair, or you can list it out with braces, showing your solution set, which is just 0 in this case. Or I'm okay with you also writing it with brackets to show your solution set, which is, again, just 0. Those all imply the same thing. They're saying that x is 0 when your y is also 0. Number 4 is asking a different question altogether. It's saying how many solutions do we have? So it's not actually asking for the solutions themselves, it's actually asking for how many we have, which we can use the discriminant for. So the discriminant just tells us how many solutions we have. We also have to understand what that really means. The discriminant, if it's positive, you have 2 solutions, 2 real solutions. If it's negative, you have no real solutions, and if it's 0, you have 1 real solution. So this is an easy way to check to see if you're going to be able to find solutions, and it's really just the part that's underneath the square root symbol, which is why a negative would give us imaginary solutions. You can't take the square root of a negative right now. So we're going to plug in B, A, and C. And we get 4 minus 24, which would give us a negative 20. And remember, in the quadratic formula, you're really trying to take the square root of that number. So this, the square root of a negative 20, that is not our answer. That's no answer. That's not an answer in any way. It's just telling us that we have no solutions. We have no real solutions because it's a negative number. These last 2 are asking us to graph the quadratic, which really just means find some coordinates that match up with that line. So you actually don't need to be given these x values. You can make up those x values for yourself and plug them in, find the y values that go along with them, and then graph them. And that's exactly what I'm going to do. I'm going to take negative 2. Actually, let's start with the easy one. I'm going to plug in 0 first. So I plug in 0 for that and that. 0 squared plus 2 times 0 minus 4. 0 squared is 0. 2 times 0 is 0. Minus 4, 0 minus 4 is a negative 4. So that's one of the coordinates that's on this curve. 0, negative 4. Let's try plugging in that positive 2 next. So I'm plugging in 2 into those 2 x values. So I'm plugging in 2 for that, and for that, 2 squared is 4, 2 times 2 is 4, minus 4, 4 plus 4 is 8, minus 4 is 4. So 2, 4, try that one again. 2, 4 is another point on that one. I'm going to keep going. Remember, anytime you plug in a negative number, you need parentheses around the number itself. So the negative 1 gets parentheses, the exponent goes on the outside of it. Plus 2 times negative 1 minus 4. Negative 1 squared is a positive 1. 2 times negative 1 is a negative 2. Minus 4 would end up giving us a negative 5. So negative 1, negative 5. And let's do one more point. Let's use blue. I'm plugging in negative 2 in parentheses squared plus 2 times negative 2 minus 4. So I'm really just substituting each of those numbers in. And I'm going to see what I get. That's 4 minus 4 minus another 4, which is negative 4 again. So negative 2, negative 4. And this is completely different from what you're used to. Typically, we're used to seeing lines, so you get a straight line where all the points can be connected. Now we're getting a curved line, or really just a curve. It's called a parabola when we have a U-shape or an upside-down U-shape. So we're going to connect these and just assume the rest of this. So let's do that in black. We're going to assume that's going to take off in that direction. This, we can see some of those points that's going to take off in that direction. It's making a U-shape because we have a quadratic where the highest exponent is a square. That's really what's telling us we're going to have a U-shape. When the biggest exponent is a 2, that is always going to give us a U-shape or an upside-down U-shape like we're going to see in the next one. Actually, I'm just going to jump straight to the end of that, where I already have my y values. I have negative 4 for negative 2, a 6 for 0, a 6 for the 3, and a 2 for that 4. I'm going to assume that we can follow order of operations and plug those numbers in. That's what we should be getting. Now I'm going to plot each of those: -2, -4, 0, 6, 3, 6, and 4, 2. Now these look like just a bunch of shuffled up points, and it's tough to tell where that U shape really is, so you might want to even plug in another number, something to fill in those gaps. I'm going to plug in -1, and I find out that I'm going to get 2 from that. So -1, 2 is another point in there. If you plug in 2, you get -4 plus 6 plus 6, that's 8. Oh, sorry, did I say -2? I meant +2. When you plug in +2, you should get 8. When you plug in 1, you actually also get 8. So I'm going to plug in 1, I get 8. Plug in 2, and I get 8. There's actually a point that's just off the graph there that's going to complete that U, and we're going to call that the vertex in a second. But that's kind of showing you where that U, or upside down parabola, kind of ends up. That is not the prettiest parabola, but you can see that upside down U shape.